A person who is 1.75 meters tall walks directly away from a light source positioned 5.25 meters above the ground, and we can see that in the diagram. If the person walks at a steady 1.5 meters per second, find how fast the length of the person's shadow is changing. So the shadow would be along here. Let's call the length of the shadow y. And let's call the distance that the person is from the light source, let's call that x. So we've got some similar triangles here. One of them goes through the person, the other one is where the light source is. And so we can do some similar triangles here. If we take y divided by 1.75, that must be equal to x plus y divided by 5.25. So basically what we're doing there is this length divided by this length must be the same as the overall length there divided by this length. So that gives me 5.25y is 1.75 x plus y. So 5.25y is 1.75 x plus 1.75 y, and that gives me that 3.5 y is equal to 1.75 x. So 2y is equal to x, and that means that y is equal to a half x. I'm not sure which one of these two is going to be useful as we go through, but we know that dx dt is 1.5. So differentiating both sides of this with respect to 2, so it's going to be that one that's useful. dy dt is going to be a half of dx dt. So in other words, that is going to be 0.75, and that one is in meters per second. We now want to know how fast the tip of the, let's get the highlighter, how fast the tip of the person's shadow is moving across the ground. Well, it's just going to be a sum of the two. This is 1.5 meters per second, and the shadow is going at 0.75 meters per second. So it's just going to be the sum of the two. So it's just going to be 2.25 meters per second.